Dear students, let's analyze another type of two-dimensional motion, that is projectile motion. We can simply define projectile motion as motion of a body after its projection is called projectile motion. When we talk about motion of a body after its projection, this is called projectile motion. And if we just talk about projection, we can simply state projection means just to throw or just to impart some initial velocity. If you impart some initial velocity to a particle, that means we are projecting a particle or we are throwing a particle. This motion we call projectile motion. There are several various kind of projectile motions, but mainly in our syllabus and at a basic level, we need to discuss about projectile motion under gravity. Mainly we'll discuss about projectile motion under gravity in this section. About different kinds of projectile motion we'll study later. Say on ground, there is a boy holding a particle. He just throws the particle, or say he is holding a ball or a stone. He throws the ball at an angle alpha from the ground with the initial speed u. We can analyze that this motion of particle will follow like this. When the stone is thrown, it first goes up, reaches some maximum height and then comes down and finally hit the ground after some distance from the point from where it was projected. This is the most simple kind of projectile motion under gravity. To analyze this motion, we just follow the same thing what we have studied earlier. If a particle is thrown with a speed u at an angle alpha, we split the whole motion in two perpendicular one-dimensional motion. Say one motion we consider in x direction and other we consider in y direction. Here x direction we consider along horizontal ground and y direction we consider in vertical direction. If we throw the particle at a speed u, we can assume that the particle is thrown in x direction with the speed that is ux. It can be written as u cos alpha, that is the horizontal component of the initial velocity. Similarly, we can also consider that the particle is simultaneously thrown in upward direction with a velocity uy, that can be written as u sin alpha. So particle starts in two directions simultaneously. One is along x direction with the speed u cos alpha, other is along vertical direction with the speed u sin alpha. As in space near to ground, gravitational acceleration g is present everywhere, but it is acting in downward direction. So we can say that this u sin alpha initial speed is retarded by this g. Acceleration in y direction can be written as minus g. And as it is in y direction, along x direction or along horizontal, there is no force acting on the particle. We can consider that acceleration in x direction of the particle is 0. So in horizontal direction, the particle moves with the uniform speed u cos alpha, as it is not having any acceleration. And in y direction, particle goes up. As particle is following this projectile trajectory, we can say its y coordinate is going up. When the particle reaches its maximum height, we can state at this point particle would be moving horizontally and its velocity in y direction is 0. So this is the point where y component of velocity becomes 0. And still as g is acting on it, it starts coming down. So as it starts coming down, its y component comes down and finally reach the ground at this point. And in this duration, we can say particle has covered some horizontal distance due to this horizontal velocity component, that is u cos alpha. So if we combine these two motions, one is the straight line motion with a constant velocity in x direction and the vertical motion, which is a free fall motion under which a particle goes up, reaches maximum height and comes down. When you combine these two, the combined effect of the two is this trajectory, which is the projectile motion under gravity. Now we are going to mathematically analyze this motion in detail. Now let us discuss some standard parameters of projectile motion on horizontal plane. Say this is the horizontal ground. We take x-axis along horizontal ground and y-axis along vertical, and if we throw a body with an initial speed u at an angle alpha with the horizontal, it follows a projectile trajectory and finally hit the ground, say at point A. In this situation from point O, when the particle started, we can state that initial velocity in x direction was u cos alpha and initial velocity in y direction was uy is equals to u sin alpha. So particle is thrown. It can be assumed that particle is thrown in vertically upward direction with the acceleration minus g. So due to u sin alpha it goes up, but it is retarded by gravity. It reaches a maximum height where you can state its final vertical velocity or y velocity becomes 0, and then it comes down and finally hit the ground. In this motion, we can calculate several parameters like the total time under which it was in motion, the maximum height attained by the projectile, and the range of this projectile that we can analyze by using x and y directional rectilinear motions. Like at t equals to 0, if the particle was started, if we wish to calculate the time taken by the particle to reach the maximum height, say this is t1. So we can very easily calculate the value of t1. That is, if you just calculate time to reach maximum height, this time to reach maximum height can be calculated by using the relation Vy is equals to Uy minus GT1. So at t equals to t1, we can state Vy is equal to 0. So we can use 0 is equals to Uy can be written as U sin alpha minus GT1. This gives us the time to reach maximum height, that will be U sin alpha by G. Actually, this is the time in which the particle has travelled from a starting point to the topmost point of its trajectory. If we calculate the total time of flight, that is the total time for which the particle was in motion, say it is capital T. So we can simply write the time which a particle takes in going up, the same time it will take in coming down. So this time of flight, capital T, can be simply written as 2t1. The time to reach up is equal to the time to come down. So it is equals to 2u sin alpha by g. You just need to keep all these results on your tips, because in several cases these results are going to be directly used. If say we are required to find the maximum height attained by the projectile, maximum height attained by projectile, if we wish to calculate this maximum height attained, that can be obtained by just using the speed equation of rectilinear motion under free fall. As the particle is thrown up with the speed u sin alpha, it goes up to a height h, then its final velocity in y direction becomes 0. So we can use the relation h is equals to ut minus half gt square, that is in time t1, the height it will attain, that is h. So h can be given as u will use as u sin alpha, and the time we use t1, this u sin alpha by g minus half g into t square will be u square sin square alpha by g square. This g gets cancelled out. You can see it as u square sin square alpha by g minus u square sin square alpha by 2g. So maximum height attained can be written as u square sin square alpha by 2g. The same maximum height you can also calculate by using the equation v square is equals to u square minus 2gh by substituting v equals to 0 and u as u sin alpha. You will see directly you will get the value of height as u square sin square alpha by 2g. If we calculate the range of projectile on a horizontal plane, that will be the horizontal distance traveled by the particle during its projectile motion. So if the particle was thrown with a velocity u, we have stated that in horizontal direction its velocity remains constant, that is u cos alpha, as acceleration in x direction remains 0. So it carries on in x direction with the same uniform velocity. And we have studied that the time it will take in going up and coming down in the projectile motion is t, and the time of flight can be given as, we have just calculated the time of flight as 2u sin alpha by g. In this time, the total distance covered by the particle along horizontal motion is the range of projectile. So we can simply state here range of projectile on this horizontal ground is equals to OA. This range can be written as the distance traveled by the particle in horizontal direction in this time of flight. That can be simply written as u cos alpha into time of flight. Because it was moving with uniform velocity, though in time t it will travel the distance u cos alpha into t, that is u cos alpha into 2u sin alpha by g. Here you know well that 2 sin alpha cos alpha can be written as sin 2 alpha. So the range can be written as u square sin 2 alpha by g. This is the expression for horizontal range of the projectile motion. Now we are going to study the range analysis of projectile motion. We have studied that in case of a projectile motion, when it is analyzed on a two-dimensional coordinate system, a particle is thrown with a speed u at an angle alpha. It follows a projectile trajectory and hits the ground at some distance away from the point of projection, and this distance OA we call the range of projectile. We have just studied that the range of projectile is given by u square sin 2 alpha by g. Here if you just carefully analyze this expression, the value of range depends on the angle of projection for a given speed. At different angles, the range will be different. And here we can simply state sin 2 alpha as a maximum value is equals to 1. Any sine function as a maximum value 1, when this 2 alpha is equals to 90 degree or alpha is equals to 45 degree. So we can see when a particle is thrown at an angle 45 degree angle, which is the elevation angle from the horizontal ground at which the particle is thrown, you can simply state the value of sin 2 alpha becomes 1. In that case, the range will become maximum, and the maximum range will be written as u square by g. So at an angle of projection 45 degree, the range of projectile will be maximum, that is u square by g. And if the angle is less than 45 degree or more than 45 degree, the range will be certainly less than this maximum range. So we can simply state, if the particle is thrown at an angle alpha, it will have a range OA. If I throw the particle at an angle of projection 45 degree, we can state its range will be maximum. This is the maximum range which is achieved when particle is thrown at an angle 45 degree. If we further increase the angle of projection, obviously the range will again decrease. That means again at some higher angle it is possible that we are going to get a range which is equal to the range which we were getting at an angle alpha, which was less than 45 degree. So we can say always at angle of projection other than 45 degree, there exist two angles of projection for which the range will become same. So we can simply write that at projection angles alpha not equal to 45 degree, always there exist two angles for which the range of projectile on horizontal ground are equal. These angles are complementary angles such that, say if these angles are alpha 1 and alpha 2, then these alpha 1 and alpha 2, alpha 1 plus alpha 2 will be equals to 90 degree, which we term as complementary angles. So if at alpha 1 we are getting some range and at some other angle alpha 2 we are getting the same range, then we can write alpha 1 plus alpha 2 will be equals to 90 degree. In various cases you can state, if we decrease the angle from 45 degree, say we throw a particle at 40 degree, that is 5 degree less than 45 degree, we are going to get some range. And if we increase the angle by the same amount, say we take 50 degree, which is 5 degree above 45 degree, so we get the same range. So if the difference of two angles are equal from 45 degree in both the directions, one is less, other is more, then the ranges will always be equal.